So we look into the work done. The total work done is basically the combination of delta work 1 plus delta work 2 plus so on up to delta work n. No wonder work total is equal to f1 delta d1 cos theta 1 plus f2 delta t2 cos theta 2 up to f and delta t n cos theta n. Okay, so fi delta ti cos theta I in general, and summation I is equal to 1 up to n. Okay, so this is the general form for collective work done when the total work done is a collection of or a summation of the differential works done. And the example is f1 delta d1, for example here and here stuff, for example f1 delta d1 f2 delta d2, and here we make theta 1 and here we make theta 2, and basically here's the xy plane. Yes, so this is how you estimate the total work done for such a situation. And we can now look into power. And for power we know that it is P is equal to W by T, work per unit time, or and work is equal to force times distance, so power becomes force times distance by time, so it becomes force times velocity. So this becomes an interesting equation for power in terms of force and velocity. So now kinetic energy in terms of momentum, another interesting manifestation. Kinetic energy with respect to momentum. Okay, So as we know that kinetic energy is equal to half mv square, and we also know that linear momentum is equal to mass times velocity. So if we take the form for kinetic energy, it is 1 by 2 mv square, and if we multiply and divide it by m, so what we get is ke is equal to 1 by 2 m square dot v square by m. Kinetic energy 1 by 2 m is equal to dot uh, or times mv whole square, which is very understandable now. Kinetic energy is equal to 1 by 2 m dot p square. Yes, so ke is equal to p square by 2 m. So this becomes an interesting form when we have kinetic energy with respect to momentum, linear momentum. Now gravitational potential, another interesting form. Gravitational potential. So work is equal to force times the dot product of force and distance. So F dot D and Ft cos theta. So basically, work is uh, the force times the distance, but we also have to take into account the angle that the force makes with the distance or the displacement. Okay, so theta. In case of gravitation or vertical situations, it is something like this. So force is upward and the displacement is the height h, and the theta it makes is, since f is parallel to h, so theta is equal to 0 degrees. Okay, so F is equal to mg, the weight in case of gravity, and cos theta is equal to 1. So W is equal to mg h dot 1, because d is h, distance is higher in this case. Work done is equal to m dot d dot h. So this is the gravitational potential. The work done uh, uh, with respect to the vertical movement against gravity of a body. Yes, so this is useful and basic to knowledge. So satellite is another topic, and we are interested in looking into the satellite basics. So satellite and the escape velocity. So this, the proposition is that the absolute potential energy is equal to the kinetic energy. So the absolute potential energy is equal to kinetic energy. Absolute potential energy, as we know, which, and we will derive this for an object around the Earth, is gme by re, where me and re are the mass and radius of Earth, and capital G is the gravitational constant. Gme m by re, and kinetic energy is the half mv square. So we can equate the two. Half mv square is equal to gmem by re. M cancels out with m on the other side, so v square is equal to gme by re. So v is equal to gme by re, okay, under the root. So this is the first thing here.